Hi, Algebra 2 students. This week we are going to continue talking about quadratic functions, and we'll be reviewing how to find the different properties of a quadratic function or the parabola. We'll be focusing in on finding these given standard form. So let's take a look at what standard form of a quadratic function looks like. You can see it right here. It's this form ax squared plus bx plus c. A cannot be 0, but B or C could be. And A, B, and C are numbers. Okay, they are constants, they are coefficients in this function. Now the different properties we'll be identifying are first the axis of symmetry. So if I draw a parabola here, an axis of symmetry is the line that divides the parabola into two symmetric parts, okay? Now, because this is a line, and it's always a vertical line, because parabolas always open up or down, they never open sideways, okay? This line will always be of the form x equals, okay? If you simply just write a number, you will get marked wrong on an assessment because this is a line. It's not just an arbitrary number. So the way you find this line is using the formula right here. X equals negative b over 2a. And the b and the a come right here from this standard form. And that's it. It's just a formula you substitute in. Okay, maybe you remember that from Algebra 1, maybe you don't, but that's why we're reviewing this. Okay, the next thing that we will be identifying is the vertex. We talked about the vertex a little bit last week when we used vertex form, and we identified the shifts up and down to find where the vertex is. So you'll notice the vertex is on the axis of symmetry. So this number that you come up with right here is your x value, okay? And then to find the y value of this point, what you do is you plug that number into your original equation. That's why it says f of negative b over 2a, because we take that number and we put it in the function, and whatever we get out is the y value. It sounds more complicated than it is, I promise. Last thing is the y-intercept. The y-intercept is just the c value. It's the very last number. It's the constant in the function. It does not have an x term next to it, okay? Now, once we find these three things, we can draw a real nice graph of a parabola. And that's what we're going to do. Oh, one more thing. We also want to be able to identify if our parabola is opening upward or downward. The way that we find that is we look at our x squared term, okay? And if the x squared term is positive, so the a, then it opens upward. If the a in the ax squared term is negative, it opens downward. When it opens downward, we say that the parabola has a maximum value because there's this maximum height that the parabola reaches. If it opens upward and a is positive, the parabola is said to have a minimum because the parabola has a bottom that it bottoms out at. It has a minimum value it reaches. So these things all go together. The a is positive, there's a minimum, and it opens upward. And then these other parts go together. If the a is negative, it opens downward, and there's a maximum. Okay, so if you wanted to make a little chart in your notes, that's how you could separate it out. So we'll try these first two examples together, and then I'll have you try the third one on your own. So example 1, identify the axis of symmetry for this graph. Okay, so the formula that we were given up above for axis of symmetry is x equals negative b over 2a. Now this is when we're working with standard form. Remember, standard form is ax squared plus bx plus c. what we're given here is not standard form. So I have a couple choices. I can use the naughty F word, FOIL. In case you didn't hear me, I said FOIL. Otherwise, distribution is the way we say it, really. So I could multiply this out using distribution, and then after that, do another round of distribution with this negative half, and then use my formula. But that sounds like a lot of work. Instead, what I notice is that this is in vertex form. And remember, when we have a parabola, the vertex is on the axis of symmetry, okay? And this is actually a poorly drawn parabola because first thing I see is there's a negative in front, so I know that this parabola opens downward, okay? I also know by looking at this function and from what we did last week that the vertex is left 5, down 8. The vertex, a point of left 5, down 8 would be negative 5, negative 8. So if I came over to my graph and said negative 5, negative 8 is right here, and it opens downward, I know that this axis of symmetry goes right through that point, negative 5, negative 8. And what is the x value of that point? The x value is negative 5. Therefore, the axis of symmetry, I'm going to shorten that throughout the rest of this with AOS, is x equals negative 5. So from vertex form, we get our axis of symmetry right from our left and right shift. Okay. Now, the next example uses standard form. So we will need to use our formula. But notice there are more steps here. Part A, determine whether the graph opens upward or downward. Well, we look at the number next to the x square, and it's positive, so it opens upward. Letter B, find the axis of symmetry. Okay, so now is when we're going to use that formula, x equals negative b over 2a. So what I'm going to do is come over here to my function, and I'm going to label each number with an A, a B, and a C, so I don't forget what they are. So x equals negative b. My b is already negative, so a negative times a negative is a positive 4, all over 2 times a is 2, 4 over 4 equals 1. Now remember, this is a line, an axis. So I can't just say 1 and circle my answer. I write x equals 1. That is my axis of symmetry. Find the vertex. So before, remember, the vertex sounded complicated. It really isn't very complicated. We just figured out that x is 1. And I have a function here that takes x's as inputs. So I'm going to put 1 in for x, and whatever I get out is y. That will be my x and y value of my vertex. So I know that x is going to be 1. Now I'm going to substitute that in. So f of x, or I should say actually f of 1, because I'm putting 1 in x's spot, equals 2 times 1 squared minus 4 times 1 plus 5. Again, I'm just plugging in x into my function, 1 into my function. So 1 squared is 1, 1 times 2 is 2, 4 times 1 is 4. And remember, we just go left to right here. 2 minus 4 is negative 2, plus 5 is positive 3. The vertex is the point 1, 3. Now I need to find my y-intercept. The y-intercept, that's the easiest one. It's just the letter C. It's the number at the end. The y-intercept you can just give as a number because we're saying where on the y-axis at 5. The y-intercept is 5. And now I'm going to graph my function. So I'm going to use all of these things to graph my function. Let's see, I think I've got some room right here on the right. So I'll draw my axes. And first thing I'm going to think about is where my vertex is going to be, and I'm going to put that on there along with my axis of symmetry. My axis of symmetry is at positive 1. So I'll put that through positive 1. My vertex is at over 1 up 3. So my vertex is going to go right here. My y-intercept is at 5. So I'll draw that on there next. I've got 1, 2, 3, 4, 5. Okay. I know my parabola opens upward, so it's going to look something like this. And to get another point on my graph, because usually 3 points is what I need to graph a parabola, remember that this is an axis of symmetry. Everything that happens on the left gets flipped over it or reflected over it on the right, and vice versa. So what we can do right now is we can just flip our y-intercept over the axis of symmetry. So I see my y-intercept is 1 away from this axis of symmetry. So I'm going to flip it over and put it 1 on the other side. And then I can complete my parabola. All right, I'd like you to take a look at this next example, this letter B, and try this one on your own. The steps are the exact same that we just went through, and then come back and check your answer.